So today is the 4th of September and the equinox is on the 22nd of September. On my channel, I have a number of videos demonstrating observations we can make on the day of the equinox that effectively destroy any possibility that the Earth is flat. And in this video, we're going to look at a new one: satellites and the equinox. Can we see the shadow of the Earth move across the line of geostationary satellites? So I have to give full credit to my friend Where's Wally for this idea. He sent me a text the other day asking if it was possible to see the Earth's shadow moving across satellites, causing them to blink out and then reappear a short time later. I thought about it, and when I realized how much damage this was going to do to flat earthers, I decided to run with it. So let's have a look at this observation and why it is so devastating for flat Earth. So this is one of my satellite time-lapse videos that I let run all night until the morning. And the current time here is 7:26 p.m. in Perth. Perth is 8 hours ahead of UTC. So if you add 8 hours to this number, you get the local time. And that means midnight is when this is showing 1600 Zulu. Now initially, I let the telescope track the stars, which means you see the satellites moving across the frame. And just before 9:30 p.m. local, I turned off the tracking and I left the mount stationary for the rest of the night. So the satellites that are in view remain in view and you see the star field moving. I'll just play this now. And I ran the time lapse fairly quickly, as you can see. There was a lot of light pollution, but as the moon set and into the early hours of the morning, there was a lot less. Now here we see the tracking on the mount has stopped. We see a number of satellites and there's just a little bit of motion on this one, indicating it's not in a perfect geostationary orbit. There's midnight passing 1600 and you can see the light pollution really drops off and it continues through until sunrise. And there's the sunrise. Now, what you noticed in that video is that the geostationary satellites that we were watching did not blink out at any point. They were illuminated throughout the entire night, including midnight. So we're now going to look at the geometry of why these satellites did not enter the Earth's shadow through the night. This app is called Luminos, and we're looking at the Earth, and these green dots represent the position of the satellites. The clearly defined ring is the position of the geostationary satellites, which have to be in orbit directly above the equator and approximately 3 Earth diameters away. Any closer, they will orbit too fast. Any further away, they will orbit too slow. Now, because these geostationary satellites are above the Earth's equator, they are also in line with the celestial equator. And if we change the view slightly, you can see that clearly. The line of geostationary satellites in line with the celestial equator. The date is currently set to the 1st of August in the app, and that means the sun is still north of the Earth's equator. It is over the northern hemisphere. On the day of the equinox, on the 22nd of September, it will cross the celestial equator and then spend 6 months over the southern hemisphere. So the reason the satellites were illuminated all night, even at midnight in August, was because of the position of the sun relative to the celestial equator and the distance of the geostationary satellites from the Earth itself. If we have a look at the geometry, the satellites that are on the opposite side of the Earth to the sun are still in clear view of the sun throughout August. As we approach the equinox and the sun moves closer to the celestial equator, the shadow of the Earth will start to block the light to some of these satellites, and we should therefore see a dark patch of them move across the sky. This is the 1st of August. Let's see what happens on the 1st of September. the sun is now closer to the celestial equator. And if we look at the geometry of that, you can see that the Earth is just starting to block the light to these satellites. As we move towards the equinox on the 22nd of September, you can see now that the sun is not visible to these satellites on the opposite side of the Earth. So they will not be illuminated. We should see them blink out and then reappear sometime later. Just changing the orientation, you can see why those satellites are not illuminated. So as we get closer to the equinox, the Earth's shadow will begin blocking the light to some of these geostationary satellites, those that are directly opposite the position of the sun, those that are above local midnight on the Earth. And that means if I was to repeat my time-lapse observation, now that we are closer to the equinox, these satellites should blink out completely, be not visible for a period of time, and then reappear as the Earth's shadow moves on. So that's the experiment that I plan to do on my first available clear night. So this is a different program, Sky Safari Pro 6, and the benefit here is that it shows you which satellites are receiving sunlight. As we fast forward the time, in September, we should now see a line of shadow move across these geostationary satellites. And that is exactly what we are seeing here. You can see this group, for example, blinks out and a short time later reappears. If I zoom out, you can see how that position of the shadow is always directly opposite the position of the sun. Let's focus in on a group of satellites here. You can see they're blinking out and then reappearing. So this is the small group of satellites that you saw in my earlier time lapse. Now, as the sun moves to the opposite side of the Earth, which is local midnight here in Perth, Australia, these satellites should blink out momentarily. There you go, they're gone, and then they reappear a short time later. And that is what we're looking for in our observation. So looking at this a different way, I have now set the date to the 30th of August, and this was before the Earth's shadow started to cut across the geostationary satellites. The local time is just after 12 midnight. Now what I'm going to do is just step forward 24 hours at a time, and you will see that now we start to see the shadow appearing, and as we get closer to the equinox, the shadow becomes wider across that line of satellites, reaching its widest point on the equinox on the 22nd. And after that, the shadow reduces in width. And by about the 16th, 17th of October, it's gone. So as we saw, the shadow starts off narrow, is widest on the day of the equinox, and then reduces in width post-equinox. If we compare the size of the shadow each day, we should have an idea of the shape of the object causing that shadow. I sent a preview of this to Where's Wally, and he did exactly that. And as we can see, the shape of the shadow certainly indicates that it could be coming from a a spherical object. And I'll just play another clip from a different app that again shows the changing position of the sun with respect to the celestial equator throughout the year. Here we have the date changing, and you can see the angle of the terminator line on the Earth is following the position of the sun. I then change the view so you can actually see the sun itself. And that helps us understand why the shadow across the line of geostationary satellites only appears close to the time of the equinox. So clearly, if we can observe the Earth's shadow moving across the line of geostationary satellites around the time of the equinox, this is extremely bad news for flat Earth. But then again, any observation done properly and analysed correctly is bad news for flat Earth. I will certainly be attempting this every clear night, and if you're in a position to do so with the right equipment, please consider trying it also. It would be great to see results from different parts of the world. So here is my trusty telescope, fully charged and ready to go. All we need is a clear night. It's actually not looking too bad. If it doesn't cloud over again later, I'll set up and try to make this observation tonight. Now NASA was so happy about this idea that they shipped me 2 brand new laptops. Check out this one. This is the one I'll be using when I do a review of Flight Sim 2020. I've had a lot of requests for that from my subscribers. So stay tuned, that'll be coming in a future video. Tell Daddy why you're happy.
Because of the one airplane.
Because of the aeroplane? Do you like aeroplanes? Are you going to be a pilot? And you want to fly the aeroplane with Daddy? That's really good. Say hello to your Nonna.
Hello, Nonna.
Say hello to your grandfather.
Hello, the father.
Say hello to Uncle Mark.
Hello, Uncle Mark.
Tell them where you are.
In the airplane.
In the aeroplane, in Daddy's aeroplane. And where are the throttles?
Here.
Excellent. And where are the flaps?
Here.
Oh, very good. Okay, say bye-bye.